Welcome to week 4 of our distance learning for now. I'm going to be breaking the lessons up into weeks. Week 1, 2, 3 we already did. This is week 4, and then each week we've broken up into parts. This is week 4, part A. So there might be part A, part B, and part C for week 4, and together they all make one lesson. Today you're going to be qualitatively describing how charges attract and repel. Repel, in case you didn't know, repel means to push away from each other. Attract means to pull together. So pushing away and attracting. I want to introduce you to the Bohr model of the hydrogen atom. This is the most simplest model of an atom that we have. The atom is made up of the proton and neutrons are in the middle of the atom, and the protons basically don't normally move, and then the electrons on the outside orbiting the protons, something like this. Now the proton is positive proton. The electron is negative. So this is what we're going to be talking about, charges, right? Because electricity is about charges, pluses and minuses. I want you to try something out. First, I'm going to talk about this guy, John Travolta. If you haven't heard of John Travolta, this is him. He was in a movie called Grease a long time ago. He was in another movie called Pulp Fiction. He seems to be dancing a lot in his movies, but he also he runs around with a gun and kills people too. So I want you guys to do is you're going to open up a simulation called John Travoltage. I'm going to pause the Ed puzzle for you, and then you will find a message that looks something like this, and you just click on the link that says John Travoltage, and it will open up a page that looks something like this. This is John Travolta, and he's standing on a carpet, and he's near a door. What I want you to do is to drag his foot and move it around and rub his foot on the carpet and find out what happens. A bunch of negative charges he picks up negative charges from the carpet, and it goes up into his body around his clothes and stuff. And so that's what the first thing happens. He seems to rub charges off of the carpet onto his foot and onto his body, and they go like this. Now what I want you to do is take his hand and bring it down close to the doorknob and see what happens. So what you probably noticed was those charges on his body, they were attracted to the doorknob for some reason. And then they even jumped across the distance between his finger and the doorknob. The doorknob is a conductor, and it conducts electricity very easily. It made a little spark. And you can notice something like this in real life if in your right conditions, especially if you're on a kind of a dry day. You can try to rub charges off a carpet and you might shock people or shock doorknobs. Let's go back to our example of the model of the atom. This is the hydrogen atom. The hydrogen atom is the most number 1 on the periodic table, so there's 1 electron and 1 proton, and we're going to be able to see these in our representations of pluses and minuses. First, I want you to imagine that we had 2 objects. I can call it a negative and a positive. It could be a sphere that's got a bunch of negatives on it, a sphere that has a bunch of positives on it, and they're hanging from a string. And if they're kind of close together like this, hanging from a string, what do you think will happen to them? What we know is when we do this, what we know, the scientists know, is opposite charges attract. So you have a plus and a minus. The electric force pulls this one this way and this one that way, and they'll be attracting towards each other because they're opposite charges. What if I did the same thing, but I had 2 negatively charged spheres hanging from strings? What do you think they will do? Well, what we know is they will do the opposite. What scientists know is that like charges repel. These charges are alike. They're both negative, so they repel away from each other. These guys will repel this way. Opposite charges attract, plus and minuses will attract towards each other, and like charges repel from each other. Opposites attract, so these plus and minus will come towards each other. Like charges repel, so negative will repel, and a positive will repel. You tell me what's going to happen if I have 2 positive spheres hanging down. What will happen to these spheres? Like charges repel. They're both like each other, so they push away like this. They will repel. What if I had a positive over here and a negative over here? What will happen to these 2 spheres? Well, we know these are opposite charges, so they'll attract to each other, so they'll pull together like this. This is actually an important concept for a bunch of reasons, but one big reason is that this is how atoms are held together. Because the center has a bunch of positive, then it attracts electrons around it. So this electron is in orbit around the nucleus of the atom because the negative is attracted to the positive, and so it orbits the proton. It's very similar to something else we've seen recently, gravitational force. Right? The Earth is in the center here, and then the moon is attracted to the Earth with a gravitational force. This is why we're studying these together, because electrostatic force and gravitational force are going to be very similar to each other. Some other small differences. Again, remember, opposite charges attract and like charges repel. That's the main idea for today. Opposites attract, like repel. The same thing happens with molecules, like water molecules, H2O. And H2O stands for two H's and an O, so two hydrogen atoms and an oxygen atom. And you can see, and what happens is all of these electrons around the oxygen atom are attracted to the proton and the hydrogen, and the electrons of this hydrogen are attracted to the protons in the oxygen, and this is what holds them together and makes chemical bonds. So this is going to be what you guys will be talking about next year, chemistry. One of the reasons we're talking about this now at the end of the school year is to get you guys ready for chemistry. Here is a model. You can see protons, electrons, proton, electrons, but basically what happens all around you, everywhere you see, for example, a sweater or a balloon or the wall, all the pluses and minuses almost always cancel out, because you have just as many pluses, protons in the middle of the atom as you have electrons around them. So this is like a model of, you can see that since they all cancel out, they end up being what we call neutral, right? Even though you have pluses and you have minuses, since the same number of each one, you add them together and they'll cancel out. So the sweater is neutral and the balloon is neutral. And the charges, by the way, are basically invisible, so you don't see them. I'm going to pause the video and I want you to open up this simulator. You're going to have a link like this. It says balloons and static electricity. So click on that and you're going to open up. Right now I have this on show no charges. I can show all the charges. I can show no charges, or I can show just the differences. This is any charges that are left over after they cancel out. They're going to look the same right now because, like I said, they're neutral. So since they're neutral, you don't see any charges right now. So what I want you to do is make a prediction. I'm clicking and holding on to the balloon right now, and I want you to move the balloon over to the sweater, rub the sweater, and then move the balloon away, and then let go of the balloon. Go ahead and do that, and then tell me what happened to the balloon after you rub the balloon to the sweater and then let go of the balloon. Alright, so if you do this correctly, what you'll see is when I let go of it, the balloon is attracted to the sweater. So now, in order to find out what actually happened, I'm going to reset it like this, and this time I'm going to show all the charges. So this time I want you to rub the balloon against the sweater, move it away, and tell me, what do you notice about what happened to the charges on the balloon and on the sweater? Okay, so what happens was, as soon as you bring them together and start rubbing them, some of the negative charges rub off of the sweater and rub on to the balloon. The balloon now has a bunch of extra negatives, and then the sweater is missing some negatives because some electrons left, and so it's got extra positives. So basically they're going to be attracted like this. Why are they attracted? If you click on show the charge differences, here's just the differences in the charge. What you notice, after I take out all the charges that canceled, you can see that the balloon has negative charge and the sweater has a positive charge. So of course they're oppositely charged and they're going to be attracted to each other. You know, the charge is conserved. You can't just create charge. You have to always, you can move charge around, but you can't create it or destroy it. If I rub more, I can rub even more, like that. And now it's going to be attracted even more. I'm going to reset it again. I want you to rub the balloon against the wall like this, and then pull it away from the wall and let go of the balloon and tell me what happens. Nothing happens. I'll move the balloon closer. Nothing happens. I'll move the balloon over here. Nothing happens. Okay? What you might notice, now do the same thing. I want you to tell me what happened to the charges. I'm going to reset it. Okay? And leave it with charges. And now I want you to rub the balloon against there with the charges and tell me what happened with the charges. So when I do this, notice nothing happens when I rub a balloon against the wall. Nothing happens to the charges. Only when I rub the balloon against a sweater does something happen to the charges. I'll kind of give you a preview. What's happening here, when I reset it, what's happening here is the material, what the objects are made out of is important. A balloon is sort of made out of like man-made sort of a plasticky, rubbery material, and a sweater is made out of cotton or wool, and a wall is made out of, like wall material. So these are 3 different materials. The material is important here in transferring charge from one thing to another. So let's figure out what we learned here. Basically, we know that the material is important. So first, going back to John voltage, this thing is called the triboelectric series. And what we found out over hundreds and hundreds of years is that different materials like to attract electrons and protons more than each other when you rub them together. These materials down near the bottom, Teflon, silicon, vinyl, polyethylene, urethane, all these things at the bottom, when you rub them with these things on top, these things really like to take and steal electrons. So they end up being negative more often than positive. The things in the middle, gold, nickel, rubber, sulfur, will still steal electrons from these things above them, but they just don't steal them as well. Now, when you go up higher on these things like cotton, wool, nylon, these things like to give up electrons, so they like to be more positive. Okay, so here's what happens with John voltage. When you rub his foot on the ground, his foot, this would not work with bare feet, because what happens is the bottom of his foot, we'll say, is basically made of rubber, right? The heel of his shoe is made of rubber. And then the carpet is going to be made of something like cotton or wool or maybe some nylon. The idea is when his shoe rubs the carpet, his shoe wants electrons and the carpet wants to give up electrons because the carpet's up here on the triboelectric series. Okay, so something like this happens. And when he rubs it together, the shoe picks up the electrons because it's down here, and the carpet and the electrons leave behind the protons in the carpet. So the carpet kind of picks up a positive charge, and his body now becomes negatively charged. And then what happens when he touches the doorknob? The doorknob is a conductor. And these charges, see, his shoe is an insulator. So the charges can't just flow down to the carpet by just stepping on the carpet. They don't flow very easily. But they would love to flow through a doorknob. The doorknob touches the wall, and then the wall touches the floor and the carpet eventually. So what happens is this. All those negative charges, they get pulled through the door and pulled through the wall and pulled back in usually to the carpet or the rest of the earth. Okay, it's called grounding. They get grounded. So they want to go back towards those positive charges, and so eventually they find positive charges and become neutral again. So that's what happens with the flow for John voltage. Something similar happens with the balloon. The balloon is made out of something like polyethylene. It's more of this type of material down here. And the sweater is going to be made out of things like wool or maybe some nylon, okay, or cotton, okay? So what happens is the sweater wants to hold on to positives and wants to give up electrons to the balloon, like this. The electrons leave the sweater because the sweater wants to give up electrons, and it goes towards the balloon. The balloon picks up those electrons, and that's how the balloon becomes negatively charged because of the triboelectric series. But when you rub the balloon against the wall is made out of things like celluloid, okay, and so it's not going to attract the electrons any more than the polyethylene, so it's really no charge changes when you rub it against the wall. Okay, so what we learned today, and we saw some examples of it, here's the big picture. Opposites attract and like charges repel. And so you can imagine the more charge you have, the more they'll attract, or the more charge you have, the more they'll repel. But it depends if they're the same charges, like charges, or opposite charges. We're going to find out in our next session that this is called Coulomb's law of electrostatic force. And it's very similar to the universal law of gravity.